Good morning, dear students. My name is Ferhan Mazher, and today is 7th of April 2021. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. And today, we have set our hearts to solve October-November 2011 paper. It's physics paper, and the number of the paper is 2-1. This is a theory paper, paper 2, we call it, and this belongs from the zone 1. This is variant 1, and in this session, in this video, we will be only solving its section A. The section B of this paper I will be solving in another session, in another video, and you can find that video on my YouTube channel. And if you go into the playlist, you will find that there we have a playlist by the name of paper 2 zone 1 section B. You can find the section B of this paper there. So let's start today's paper, and let me show you. Okay, sorry, we have to. Okay, so this is October November 2011, and this is 2-1 paper, and I'm going to solve the section A. Question number 1 shows an ice cube at 0 degrees centigrade. The sides of the cube are length 0.040 meter. Ice at 0 degrees centigrade has a density of 920 kg per meter cube. The first question is calculate the mass of the ice cube. You know, if you want to find out the mass of the ice cube, the density is given. You can find it. If I need to know the volume. The volume of the cube can be found by length multiply length multiply length, and the length is 0.040 meters. So simply multiply 0.04, multiply 0.04, multiply 0.04, multiply this like this, and you get the volume. Once you have the volume, then I can use the formula density is equals to mass divided by volume, and mass will be equals to density. Density is equals to mass divided by volume. So if you want to find out the mass, it will be density multiply volume. And then the next question is the weight of the ice cube. Once you will have the mass, then you will be able to find out the weight of the ice cube. That is a 1 mark question. Weight is W is equals to mg. So if you have the mass in kg, you can easily find this. I have done this on a paper. Let me show you my work. These two parts. So here we go. The mass is equals to density multiply volume. So the mass is equals to 920 multiply 0.04 multiply 0.04. By mistake, I just have written here 0.4. It is 0.04 multiply 0.04. So the final answer will be 0.05 kg. So if you want to find out the weight will be equals to W equals to mg equals to 0.059 multiplied 10 and 0.59 Newton. So that's question number 1, A part, first and second portion. So let's check the marking scheme if our answers are right. So you can see, yeah, 0.05 kg and 0.59 Newton. Our answers are perfectly right. Okay, so next question on your screen is the specific latent heat of fusion of the ice is 3.4 expo 5 joules per kg. Calculate the thermal energy absorbed by the ice cube as it melts when a state change is taking place. For example, the ice is melting at 0 degree centigrade. We can find out the amount of heat absorbed, and that is heat is equals to m multiply L, where m is the mass of the ice and which is melting, and L is the specific latent heat of fusion. So heat is equals to m multiply L. Simply put the value of m and L, and you will find the heat involved. So let me show you. I have done this on a paper, and I think this is showing on your screen. Heat is equals to m multiply L, 0.059 kg multiply 3.4 expo 5 joules per kg, and the final answer will be 20060 joules. So hopefully this is the right answer. Let me check from the marking scheme also. The marking scheme says 2.006 expo 4 joules. So our answer is right. So we are done with the question number 1. Hopefully you have understood it. Question number 2. So let me reduce the size so you can understand it. Figure 2.1 shows an elevator lift that is supported by a cable. The cable passes around the axle of an electric motor and over a pulley. The cable is then attached to a concrete block that has the same mass as the empty elevator. As the elevator moves up, the concrete block moves down. So you see the mass of this concrete block and this elevator both have the same mass. So the weight of this concrete block is acting downward, and through this cable, this concrete block is connected with this elevator. So the when the concrete block will go down, and this will lift this elevator upward. So the very important point is this, that the weight of the elevator is balanced by the weight of the concrete block. The concrete block will create tension in that cable, and that tension will be acting upward on the side of the cable, which is on the elevator side. The tension will be in the upward direction, and the weight of the elevator will be downward direction. So the tension in in that cable and the weight of the elevator, they will be balanced. So in simple word, you can say that the weight of the elevator is balanced by the weight of the concrete block. Question is, explain why very little work is done by the electric motor when lifting up the empty elevator. Now the electric motor don't have to lift the weight of the elevator. The electric motor don't have to lift the weight of the elevator. The weight of the elevator is balanced by the weight of the concrete block. The electric motor only has to provide energy to overcome the friction in its pulley, in its axle of the motor. The electric motor has to only provide energy to overcome the air friction. The electric motor has to only provide the energy to accelerate the elevator. The electric motor don't have to provide the energy to to balance the weight of the elevator. The weight of the elevator is already balanced by the concrete block. So this electric motor has to do very little work because it don't have to lift the weight of the elevator. The weight of the elevator is already balanced by the weight of the concrete block. So I have written this answer. Let me show you my answer. Little tricky question, but let's see. Weight of the concrete block creates tension in cable, which balance the weight of elevator. So electric motor has to only provide energy to overcome air friction and friction in axle of pulley. So let's check the marking scheme. What the marking scheme says? Marking scheme says work is done by the falling block. Falling means falling down. A block or block loses gravitational potential energy or energy transferred from block to elevator, or force is balanced. Their weights are balanced of the concrete block and the elevator. Work done by falling block raises the elevator or converted to GP, gravitational energy of the elevator, or the work done against the friction, air resistance, or work done to accelerate the elevator. So this last point is very important. The answer I have written, I think that will be good. You can also write a good answer. So the electric motor has to only provide energy to overcome air and friction in axle or pulley, or to it only has to provide the energy to accelerate the elevator. You can add this point also. The electric motor only has to provide the energy to accelerate the elevator. So let's go to the next part. It was my 2-mark question. Now several people of total weight 4900 Newton are traveling upwards at constant speed in the elevator. They rise through a distance of 24 meters in 28 seconds. Calculate the minimum power output of the electric motor. The power is equal to work done divided by time. And work done in this case is equal to the weight multiply height. Weight multiply height divided by time. That is how you calculate the power. Let me show you my work. I've done this on a paper. Let me show you that. So here you can see the power is equal to weight multiply height divided by time. So 4900 Newton multiply 24 meter divided by 28 seconds. So the final answer will be 4200 watt. The final answer will be 4200 watt. Let me show you the marking scheme. The marking scheme say 4.2 kilowatts. So our answer is perfectly fine. You can see question number 2B part showing on your screen. And we are done with the question number 2. Hopefully you have understood this. Okay. So now we are moving to the next question. He says, figure 3.1 shows the flame of a Bunsen burner. A thermocouple thermometer contains a voltmeter. It is used to measure the temperature in the flame of the Bunsen burner. On the figure 3.1, draw a label diagram of the structure of the thermocouple thermometer as it measures the temperature in the flame. So I have to draw here a thermocouple thermometer. I have done this on a paper. Let me show you my work. You see the thermocouple thermometer I have drawn here. Thermocouple thermometer is made by two different metals. One, it uses two wires. Each is made of different metal. For example, there the black wire is made of iron and the blue wire is made of copper. Their ends are joined together. The one end is put on the flame. We call it the hot junction. The other end, where the two wires are twisted with each other, and that is called the cold junction, that is put in the melting ice. In the copper wire, we have connected a voltmeter. Whenever the hot junction and the cold junction, there is a temperature difference between both the junctions. Naturally, automatically, EMF is generated, and the voltmeter shows deflection. The deflection on the voltmeter is directly proportional to the temperature difference between the hot junction and the cold junction. So greater the temperature difference between the hot junction and the cold junction, the greater will be the reading on the voltmeter. And the smaller the difference of temperature between the hot junction and the cold junction, the smaller will be the reading on the voltmeter. So that voltmeter reading can be calibrated for temperature. So this is what you have to do. So you can see question number 3. He says one junction in flame and the 3 wires and fixed point ice bath, or 2 wires, 2 different metals and voltmeter connected. We have made that thermocouple thermometer which has 2 wires. The next question is, let me show you the next question. He says, describe how the fixed points and the reading of the voltmeter are used to determine the value of the temperature in the flame. Try to understand this. So what we do, we have thermocouple. Thermocouple has 2 junctions. One is called the hot junction. The other one is called the cold junction. For the fixed points, the cold junction is dipped or put in the melting ice cubes whose temperature is 0 degrees centigrade, and the hot junction is put in above a cylinder, above a beaker, from which the steam of the boiling water is coming out. And we suppose that its temperature is 100 degrees centigrade. So the cold junction will be at 0 degrees centigrade and the hot junction will be at the 100 degrees centigrade. And whatever the reading on the voltmeter will come, I will call it EMF1. Then I will take the hot junction, I will put it in the flame of the Bunsen burner, and the cold junction still will be in the melting ice cubes. And then I will note down what is the reading on the voltmeter. Now I will call it EMF2. Then I will use the formula theta minus 0 divided by 100 minus 0 equals to EMF2 divided by EMF1. So I have written this on my paper. Let me show you this. Put hot junction in steam at 100 degrees centigrade and cold junction in melting ice at 0 degrees centigrade. Note EMF1 on the voltmeter. Put hot junction in the flame of the Bunsen burner and cold junction in melting ice at 0 degrees centigrade. Note EMF2 on the voltmeter. Use this formula theta minus 0 divided by 100 minus 0 equals to EMF2 divided by EMF1. And very easily you can find out the temperature of the flame. So if you look at the marking scheme, question number 3, part A, part 2, he says He says voltmeter reading voltage at fixed points, for example, V naught and V100. Compare the voltage of the flame with the voltage of the fixed points to obtain graph, equation, or words. Okay. So we have done perfect answers. So you can also check the marking scheme here. So I think that we have written the perfect answer. Okay. So the next B part of the question number 3. He says the thermocouple thermometer is used to measure the temperature in the flame because it can measure very high temperatures. State and explain one other advantage of using a thermocouple thermometer to determine temperature. If you want to find out the temperature of that flame, uh, so what is the advantage of using this thermocouple thermometer? One advantage he has already told. The one advantage is that the thermocouple thermometer, it has a wide range. It can measure very high temperatures. It can also measure very low temperatures. So you see that the thermocouple thermometer, it has this advantage of the very large range. And other benefit of the thermocouple thermometer is that it can measure very rapidly changing temperatures. You see we can connect the reading on the voltmeter to a data logger and then to a computer, and by using a software we can plot a graph between the temperature and the time. And if the temperature will be changing very rapidly, computer will draw a cooling or heating curve for us. So I can note down very rapidly changing temperature. Another advantage of the thermocouple thermometer is it's very robust. Robust means you can take it anywhere. Another advantage of this thermocouple thermometer is that it can take remote readings. Remember this word, it can take remote readings. Remote reading, what does remote reading mean? You see this iron wire and the copper wire, you can make it like 4 meter long. And I will call it probe. And by standing, let's say 3 meter away from a hot body, you can put the hot junction in the hot. You can put the hot junction of the thermocouple in the hot body, and you still will be 4 meter away from that hot body. For example, a furnace. For example, a lava, and they are very hot. You cannot go near them. So if you make the wire of copper and the iron longer, so then you can stand at like a distance of 6 meters from that body, hot body, and still you can take the temperature. So you can take remote temperature with the help of the thermocouple. I think there are enough advantages. I have written this advantage. So let me show you. Okay. So thermocouple thermometer take remote measurement. By making wires longer, user not need to be near thermometer. You see, remote readings mean that you make those wires longer. So the hot junction will be like 4 meter away. So by taking, you stand 4 meter away from that hot furnace or flame, and you just put the hot junction there, and you are like 4 meter away from there. So this is how this is done. I think you have understood. And let me show you one very important thing. Let's say, let me show you the marking scheme or the marking scheme. Question number 3, B part is showing as marking scheme on your screen. Any one of, for example, rapidly varying temperature. So small heat capacity, it says remote, I can take remote measurement. Remote measurement means that the user not near the thermometer. And you can also direct input to the computer. So because it has electric output, the voltage is electric output, so you can feed it to the computer through a data logger, and the computer will, by using appropriate software, we can draw a graph of the temperature and the time. So these are the advantages of the thermocouple thermometer. So let's start the next one. Question number 4. Question number 4 is figure 4.1 shows glass lens in air and its two focal point f1 and f2. So f1 and f2 on both sides of the converging lens are shown. He says 3 rays of light pass through f1 to the lens. On the figure 4.1, continue the 3 rays through the lens and into the air. It's a 2-mark question. So here you can see there are 3 rays. They are passing before entering into the lens. They are passing from the focal point on that same side, f1, and then they go through the lens. So we have to draw how they will travel after passing through the lens. I've done this on a paper. Let me show you my work. And here we go. Okay. So you can see there are 3 rays. The middle ray, which is passing through the optical center, and it's a very famous property that the ray which passes through the optical center do not deviate. Because it do not deviate, it goes straight. I have shown it with the green color. Thus, I use the color just simply to tell you the difference that this is ray 1, this is ray 2, this is ray 3. Then the other one, like the red one, which went up because it passes through the focal point before entering into the converging lens. This ray, after passing through the converging lens, will become parallel to the principal axis. So you can see that after passing through the lens, I have shown it with the red color, and it has become parallel to the principal axis. In the same way, the third ray, which passes through the f1 before entering the converging lens, when it will pass through the converging lens, it will become parallel to the principal axis. I have shown it with the blue color. You can see this ray will become parallel to the principal axis. So it's a 2-mark numeric, 2-mark diagram, and I hope you have understood. Let's check the marking scheme. Question number 4, A part. 1 outer ray parallel to the principal axis, 3 rays parallel to the principal axis. All of them, after passing through the lens, will become parallel to the principal axis. Okay, so next question number 4, and it is B part. Okay, state what happens to the speed of light on entering the glass lens from the air. Remember, this is the behavior of the light. That light travels faster in air. Thus, light when enter into the glass, its speed will slow. This is the behavior of the light. When the light travels in the air, its speed is more. When it travels in the glass, its speed will be comparatively less. So he says, state what happens to the speed of light entering the glass lens from air. When the light will enter into the glass lens from the air, the speed of the light will decrease. The second part is leaving the lens and returning into the air. When the light will enter from the glass into the air, its speed will increase. The speed of the light in air is larger than the speed of the light in the glass. I hope you have understood. Let's do the next part. We will check them later. Light of wavelength 6 expo minus 7 meter travel in air at a speed of 3 expo 8 meter per second. Calculate the frequency of this light. You see the wavelength is given. The speed is given. The frequency is questioned. Famous wave equation, V is equals to F lambda. V is equals to F lambda. If I know the velocity, the speed, and if I know the lambda, I can find out the frequency. I've done this on a paper. It's a 2-mark numerical. Let me show you my work. Okay. So this is the first part and second part. Speed of light will decrease when it enters from air into glass. Speed of light will increase when it enters from glass into the air. This is the second question number 4C, first and second part. The famous equation V is equals to F lambda. F will be equals to V divided by lambda. The velocity is 3 expo 8 and the lambda is 6 expo minus 7. Just enter it into your calculator and the frequency will be 5 expo 14 hertz. So this is that part, and then in the next part he asked a very important question. He says, state the effect, if any, on the frequency as the light enters the glass from air. You know, when the light will enter from glass into air or from air into glass, no matter what are the mediums, when the light enters from one medium into the other, into another medium, the one thing which do not change is the frequency. The frequency of the light will not change. The frequency of the light will not change when it enters from glass into air or from air into glass. The frequency of the light will not change. Let's check the marking scheme. This is question number 4. I think question number 4 is done. Yeah, we are done with the question number. No, we are kind of done. Let's check the marking scheme. So 5 expo 14 hertz will be the answer of that numerical, and he says on the frequency there will be no effect, unchanged, or he has given you the value of the frequency also, 5 expo 14 hertz. So we are done with the question number 4. We are moving to the question number 5. Let's see what the question 5 is. Figure 5.1 shows a nylon rod being rubbed with a woolen cloth. Figure 5.1 shows a nylon rod being rubbed with a woolen cloth. The rod becomes negatively charged. You see, you rub them with each other and the rod became negative. Explain how rubbing the nylon rod makes it negatively charged. You see, when you rubbed the nylon rod with the woolen cloth, due to the friction, the electrons have transferred from the cloth onto the nylon rod. When you rub the nylon rod with the cloth, you see what happened. The electrons have traveled from the woolen cloth onto the nylon rod. This is why the nylon rod has become negative. So it's a 1 mark question. Let me read my answer. Due to the rubbing, electron has transferred from the cloth to nylon rod, which make it negative. This transfer of electrons has made the nylon rod positive. The next question is, what will happen with the cloth? So if the electrons from the cloth has gone to the nylon rod, the cloth has deficiency of electrons so the cloth will become positive. The cloth will become positively charged. So let's check the next question also, and then you see the A first part and second part. First question was explain how rubbing the nylon rod makes it negatively charged, and the second part was state what happens to the cloth as the rod becomes negatively charged. Let's check the marking scheme for these two parts. Electron moves to the rod, 1 mark for this, and becomes positively charged, loses the electron. Very simple. Okay. So the next question, he says the figure 5.2 shows the negatively charged rod placed near to a conducting sphere. The sphere is suspended by an insulating thread. On the figure 5.2, draw the distribution of the positive and negative charges on the sphere. So because this sphere is conducting and it's near this negatively charged rod, so what will happen? The electrons will be repelled by this negative charge, this negative rod. So the free electrons, they will go on to the left side of the sphere. So this right side of the sphere, it will become deficient in electrons. So this will become positive. And the left side will become negative. So the positive side of this sphere will be positive, and the left side of this sphere will be negative. Let me show you 2 marks, and you have to work on the diagram. I've done this, and let me show you. Yeah. You see, So when you brought this metal rod near this negatively charged sphere, so from the right side of the sphere, the electrons, the free electrons, they will be repelled and they will go to the other side. So the right side will become positive and the left side of the sphere will become negative. The right side, if for example I have shown here three positives, so on the left side you will show three negatives. For example, if you show four positive on this side, on the right side, then you will also show four negative on the left side of the metal sphere. So it's a two-mark diagram where you have to show the charge on the metal sphere. He says, explain why the sphere is attached to the rod. You see, try to understand this logic. Try to understand my logic. So why this sphere will be attracted to this negative rod? The right side of the sphere is positive. So it will have attraction with the negative rod. The left side of the sphere is negative. So it will have repulsion with the rod because the rod is also negative. The force of attraction here will be greater than the force of repulsion. The force of attraction is greater. The reason is that the distance between this positive side and this negative rod is smaller. So their force of attraction is larger. The force of repulsion is smaller. The reason is that the distance between the negative side of the sphere, which is left side, and the negative rod is larger. So their repulsive force will be smaller as compared to the attractive force between the positive and negative. So that's why the sphere will be attracted to this negative rod. So I have written this answer also. Let me show you my answer. And here we go. I've tried to write this answer also. Right end of the sphere is positive and it will have attraction with the negative rod. Left end of the sphere is negative, it will have repulsion with the negative rod. Attractive force is stronger than repulsive force. The reason is the distance between the positive side of the sphere and the negative rod is smaller. That's why that force of attraction will be larger. The force of repulsion is smaller. The reason is that the negative side of the metallic sphere and the negative rod, the distance between them is relatively larger. So the force of repulsion will between them will be weaker. So let me check the marking scheme, what the marking scheme says. Yeah. B second part, question number 5, positive charges attracted, attraction larger than repulsion or positive closer than negative to the rod. I hope better you have understood this. A little difficult answer. This last one is little difficult to write. Okay, so we are moving to question number 6. He says, when a car is moving, its electrical equipment is powered by an AC generator. The coil of the AC generator is rotated by the car engine. On the axis in the figure 6.1, sketch a graph of the output voltage of the coil against time for 2 rotations of the coil of the generator. So you have to draw 2 waves at least. So because the alternating current is produced and the alternating current goes in the positive side of the voltage, it also goes on to the negative side of the voltage. I have drawn this. Let me show you my work and then we will see what you understand. So here I have tried to make 2 waves. You see, so this black wave is basically showing the voltage output. It goes positive, then it becomes 0, then it goes negative, then again 0, and then it is positive. So this is alternating current. This is how the alternating current will be shown on a voltage time graph. I hope you have understood this. And let me check the marking scheme. What the marking scheme says for the question number 6. Recognizable sine cosine curve. This wave, this up and down wave, like ripples in water, and they are called sine waves. Okay. The next question is, he says the speed of the car increases and so does the speed of the rotation of the coil. State 2 changes that this causes to the output voltage. Try to understand. If you increase the speed of the generator, the coil of the generator is rotating. If you increase the speed of the rotation of the coil, so what will happen with the output voltage? The output voltage value will become larger. The output voltage will become larger. So when you draw it on the graph, whatever is the amplitude of that graph right now, that amplitude will increase because the output voltage will be larger. So the graphs will have higher amplitude now. And the second difference is when you move the coil of that generator faster, the current produced, its time period becomes smaller. The time period of that wave will become smaller. When the time period will become smaller, the frequency will become larger. The frequency will become larger, the time period will become smaller. I will check this from the marking scheme also. Then the B part is when the car engine is off, the current in the lamp from a 12-volt battery is 0.050 ampere. Calculate the resistance of the lamp. You see, so simply apply the formula V equals to IR. V equals to IR. If you know the voltage, you know the current, simply put the values, you will be able to find the value of the R. R is equals to V divided by I. R is equals to V divided by I. I've done this on a paper. Let me show you my work. So let me show you my work and then we will check the marking scheme also. Okay. So the amplitude of the trace will be larger because higher voltage will be produced. So when the coil will be rotating faster, the higher voltage will be created. More waves will be on display because time period has decreased and the frequency has increased of the voltage. This last one is little tricky. Time period will become smaller and the frequency will become larger. So on the display there will be more number of okay, question number 6, B part. V is equals to IR. R will be equals to V divided by I. The value of the V is 12 and I is 0.5 ampere. So the final answer will be 24 ohm. 24 ohm. Let's check the marking scheme. Let's check the marking scheme. Yeah, better you can see larger peak voltage, higher frequency, shorter period described in per shorter wavelength. R is equals to V divided by I. So the final answer will be 24 ohm. So I hope better you have understood the question number 6. Okay, so we are moving to the question number 7. Figure 7.1 is the circuit diagram for the volume control of a loudspeaker. You see, here we have a variable kind of resistor. Here I have a loudspeaker which is connected to one end of that resistance, and the other side of the loudspeaker is connected with the movable contact, which is S, and that contact can move. It is also a basic diagram of a potential divider. So, for example, where you have put the contact right now, the resistance above that point, the wherever is the S right now, the portion of the resistance which is above that S, that will be called R1, and the resistance between S and C, that will be called R2. Connect this diagram with the potential divider. So whatever will be the voltage drop across the R2, that is fed to the loudspeaker. So if the voltage across SC or R2 will be larger, the loudspeaker will have larger voltage, and the sound produced will be louder. If the R2 value or the resistance between S and C, that will decrease. The voltage drop across it will decrease. The voltage which is fed to the loudspeaker, that will decrease, and the sound will become less dense. The sound will become fainter. So connect this whole thing with the topic of potential divider and the formula of the potential divider. Okay, and very important thing. You see, when you will move, this is also the question. The circuit includes a variable potential divider potentiometer. The input voltage is connected across the ends of the potential divider. The loudspeaker is connected between the sliding contact S and the terminal C. The sliding contact S is moved towards C. State and explain the effect on the sound produced. When you will move the S towards C, you see the length of the R2 will decrease. The value of the R2 resistance 2 will decrease. So the voltage drop across the R2 will decrease. So the voltage given to the loudspeaker will decrease. So the sound produced by the loudspeaker will become fainter. So as the contact C is moving, contact S is moving towards C, the R2 value is decreasing gradually. The V out from the R2 fed to the loudspeaker is gradually decreasing. So the sound produced by the loudspeaker, that will be also less loud and less loud. It will becoming faint and fainter and fainter. This is question number 7A part. It's a 2-mark question, and I have tried my best to explain you what will happen. So let us read this my answer which I wrote. As the sliding contact moves towards C, resistance R2 will decrease. V out will decrease, so the voltage provided to the loudspeaker decreases. So the loudness of the sound will gradually decrease. Understand? I hope you understand. So let's check the marking scheme. This is question number 7A part. Question number 7A part, you can see 2 marks are there. 1 mark is volume decreases, quieter, less sound. In some way, resistance between S and C decreases, or in some way, voltage. And 1 mark is for saying the loudspeaker reduced, the sound of the loudspeaker reduced. I think you have understood. I have tried my best to explain this concept. Let's move to the next part. So, question number 7, and it's B part. The loudspeaker emits a sound of constant pitch. Over a period of time, this sound becomes louder and louder. State the fact if any of the amplitude and on the amplitude and on the frequency of the sound wave during this time. The amplitude. Because the sound is gradually becoming louder and louder and louder. So it means that the amplitude of the sound wave is increasing. The loud sound has higher amplitude, larger amplitude, and the fainter sound has smaller amplitude. Because the sound is becoming louder and louder and louder, that's why this amplitude is becoming larger and larger and larger. The pitch of the sound is constant. You know, the pitch of the sound depends upon the frequency. So because the pitch of the sound is constant, that's why the frequency of the sound will be unchanged. It will be constant. It will not change. So I have written this answer also. Let me show you my answer. The amplitude increases, the frequency remains constant. It's a 2-mark question. Very simple. I hope you have understood. So by this, we are done with the question number 7 of this paper. So we are moving to question number 8. One radioactive isotope of iodine is iodine 53-131. As a nucleus of this isotope decays, it emits a beta particle, symbol B, and it becomes a nucleus of an isotope of xenon, symbol ZXE, and complete decay in the nuclear form for this decay. You know, whenever a beta particle is given out, whenever a beta decay happens, whenever a beta particle is given out, the daughter nucleus the daughter nucleus will have one extra proton in it. The daughter nucleus, the proton numbers in the daughter nucleus will be one more than the proton number of the parent nucleus. So if the parent nucleus have 53 protons, the daughter nucleus will have 54 protons. That is the signature of the beta decay. Whenever a beta particle is given out, the daughter nucleus proton number will be one more than the proton number of the parent nucleus. So the xenon downstairs you will write 54. And when the beta decay happens, the mass number do not change. There is no change in the mass number. So the mass number of the xenon will be 131. So the proton number will become 54 and the mass number will still be 131. And for the beta particle downstairs, you will write -1, and on the top, you will write 0. I have written this equation. It's a 2-mark equation, very important, not very difficult. Okay. So you can see on your screen, this is showing the thing which you need to remember is then whenever a beta decays happen, the daughter nucleus will have one proton number more than the proton number of the parent nucleus. And the mass number will not change. But the number of neutrons will be one less as compared to the number of neutrons in the ion. So hopefully you have understood. This is about the beta decay. I think I have made this point clear. So let's go to the marking scheme. What the marking scheme says. Okay, see question number 8. A part, the marking scheme is showing on your screen. And I think that our answers are perfectly fine. A part is good. So we are good to go to the next part. And the next part is, he says a sample of radioactive isotope emits both beta particle and gamma rays. Figure 8.1 shows these two types of radiations entering a magnetic field. The magnetic field is into the page. So beta particles and the gamma rays are coming. You see, the direction of the magnetic field is into the page. On the figure 8.1, mark and label the path taken by the beta particles and by the gamma rays. Try to understand. I've drawn this on first of all, I will use for the gamma rays. It's very simple. You see, the gamma rays are neutral. The magnetic field will have no effect on the gamma rays. So the gamma rays will go straight. They will go straight undeflected by this magnetic. But you see, when the beta particles will enter into this magnetic field, they will be deflected. And in which direction they will deflect, I can tell you by the left hand rule. It says, the left hand rule says stretch the 3 fingers like this. And the 3 fingers, the thumb, the forefinger, and the index finger. Sorry, the thumb, the index finger, and the middle finger. They are stretched in such a way they are perpendicular to each other. They make 90-degree angle with each other. So stretch the fingers of your left hand in such a way. Thumb, index finger, and the middle finger. They are perpendicular to each other. You see, this is how I stretch it. So I call FMC. FMC. Force, magnetic field, current. So the beta particles are entering into the magnetic field and they are going towards from left to right. Okay. So the current will be like this, from left to right. The magnetic field is into the screen. So I will point into the screen. My thumb is pointing upward. But my thumb is pointing upward. It means the beta particle should be deflected towards the top of the page. But there is a problem. This law is not for the beta particles. This law, because the beta particles are negatively charged. This law is not for the negatively charged bodies. This law is not for the negatively charged particles. This law is for the positive charges. This law is for the conventional current. But there is no problem. Wherever your thumb is pointing, so the current is going this way from left to right, the magnetic field is into the screen, into the page. My thumb is pointing upward because these are beta particles. Because these are beta particles, their deflection will be, their deflection will be opposite to whatever your thumb is pointing. Wherever your thumb is pointing, it is pointing towards the top of the page. So the beta particle should be deflected towards the bottom of the page. The reason is the beta particles are negatively charged, and this law, this left hand law, in this, the current is due to the positive charge. I've drawn this on a paper. I tried my best to explain to you that. So now you can see that I have shown here a magnetic field with the crosses. When I show the magnetic field with the crosses, it means that the magnetic field is into the page, into the screen. The beta and the gamma rays are coming, and when they entered into the magnetic field, the beta particles have deflected downward. When I apply left hand rule for this, FMC, magnetic field into the screen, the current is going this way. My thumb is pointing upward, but with beta particles, because they are negatively charged, and this law is about the positive charges, so their deflection will be opposite to whatever my left hand rule is saying. So the beta particles bend it downward. The gamma rays, on the other hand, I have shown them with the blue color. They are neutral, they don't have charge on them, so neither they are attracted nor repelled. Magnetic field has no effect on them, so they go undeflected straight. So I hope you have understood. So let's take the marking scheme. And the marking scheme says, is a downward curve and horizontal line. For gamma, it will be horizontal line, and for the beta particle, it will downward curve. Okay. So the next question: emission from a radioactive source is a random process. State two ways in which the process is random. So you see, we normally say that the radiation is a random process. So why we say the radiation is random process? One, I can give you few logics. That if you have a sample of radioactive isotope, you never know which atom will decay. You cannot predict that which atom will decay. You cannot predict the time duration between one decay and the next decay. If you are using a detector with the help of the to measure the decay rate, you will observe that after 1 minute the reading is different. So this means that the radioactive emission is a random process. I have written this answer, ma'am. Let me show you my answer, and then we'll check the marking scheme. So we cannot predict which atom will decay. This is the meaning of randomness. We cannot predict that which atom will decay. We cannot predict the time duration between one decay and the next decay. So that's why we say that the radioactive decay is a random process. You cannot predict it. Okay. So C part, question number 8. Any two of direction, space of emission, time, frequency of emission, and direction, space of emission, time, frequency of emission, or period interval between the emissions or different counts in the same time. Nucleus that decays is unpredictable. We cannot predict. So this was question number 8, the whole marking scheme question. So I hope that you have understood this thing. And by this question, we are at the end of this section A. Today we have solved, today we have solved, you see, after this, the section B will start. And the section B I will do in another session, in another video. So I have already done that, and that is in my YouTube channel. You can find it there. So today, my dear friends, we have done, okay, so this is the paper. Today we were doing October, November 2011 2-1 paper. And in this session, we have only done the section A of this paper. It was a theory paper. We call it paper 2, and it belongs from the zone 1. So I have tried my best to explain you the concepts. I hope that you have learned, you will learn some good things from this video. I always suggest that if you want to do the best learning, you should have the hard copy of this paper, and then you should watch these videos. So because if you have the hard copies of this of that paper, and then you are watching this video, so listen to my description and then what I have written. And the most important thing which you have to do is you have to look at the marking scheme carefully, because you see, I am also human, I can make errors. I try, I don't make error, but we are human, we can make error. So it's very important that whenever you attempt a question, you check your marking scheme. So if this video is helpful to you, if you have found that this video is helping you in improving the concepts of your method of your physics, kindly subscribe to my YouTube channel and also suggest these videos to your friends, because by sitting at your home, by just switching to this channel, you will be able to solve the past papers of the physics O level 5054. So thank you very much, everybody, and have a good day, and God bless you all. Thank you.